Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss trigonometric functions. We are going to discuss trigonometric functions. Exercise 3.2. Exercise 3.2. Concepts or points. The concepts or points which are useful, which will be used in the exercise 3.2, we are going to discuss now. Are you ready to listen the class, my dear children? Right. See here, sometimes in the questions they will give angle theta lies in the first quadrant, and they will give the value of any one of the trigonometric functions of this angle theta. Means sometimes they will give the value of sin theta, or the value of cos theta, or the value of tan theta, or the value of secant theta, or the value of cosecant theta, or the value of cot theta. They will give in the question. Any one of the trigonometric functions value will be given, and they will ask find the values of the remaining trigonometric functions. Okay, my children, in that case, this diagram, this figure is very useful. In that case, we have to draw a triangle of reference. We have to draw a triangle of reference. Observe here what is given lies in the first quadrant. Angle theta lies in the first quadrant. So here angle theta is in the standard position. How can you say an angle is in the standard position? Its initial ray must be positive x-axis, and vertex must be origin. If the vertex of an angle is origin and initial side of the angle is positive x-axis, then the angle is said to be in the standard position. Okay, my children, do you remember that point? Right. Now come to this angle theta. Here what is given? Theta lies in the first quadrant. When do you say that angle theta is lies in the first quadrant? The terminal side of the angle theta must lie in the first quadrant. Here OP is the terminal side of angle theta. OM is the initial side of angle theta, and OP is the terminal side of the angle theta. Then if we observe here, vertex of this angle is origin, and initial side is positive x-axis, and terminal side lies in the first quadrant. Then we say that theta lies in the first quadrant. And if theta lies in the first quadrant, we draw like this. Terminal side of the angle must be in the first quadrant, like this. After that, we have to draw a perpendicular line like this. We have to choose any point on this ray. On this terminal side, we can choose any point on the terminal side. From that terminal side, we have to draw a perpendicular line to the OX axis. OX. Okay, my children. Then we get a right angled triangle. A right triangle. This triangle is said to be triangle of reference. With the help of this triangle of reference, we can find the remaining values of trigonometric functions. Okay, my children. Similarly, we discuss the remaining cases also. I mean the angle, if the angle lies in the second quadrant, if the angle lies in the third quadrant, if the angle lies in the fourth quadrant, what is the diagrams, what are the figures of triangle of reference? Okay, my children, right. Sometimes they will give in the question as an angle theta lies in the second quadrant. In that case, how to draw the triangle of reference? Okay, my children, see this figure. See this figure 2. If angle theta lies in the second quadrant, then the triangle of reference will be in the form of like this. We draw a triangle of reference like this. Angle AOP is theta. See here, Angle AOP is theta. Here the angle AOP is in the standard position because OA is the initial side of the theta and OP is the terminal side of the theta. Origin is the vertex of the angle theta. Then see the OA initial side is positive x-axis. Then what is the quadrant in which the angle lies? Yes, second quadrant. How can you say it lies? So here we can say that angle theta lies in the second quadrant with the help of the position of the terminal side of the angle theta. In which quadrant the terminal side of the angle theta lies? See here OP. OP is the terminal side of the angle theta. It lies in the second quadrant. Therefore, we can say that angle theta lies in the second quadrant. In that case, we have to draw a right triangle like this. We have to choose any point P on that terminal side. We assumed here PB any point on this terminal side. From this point, we have to draw a perpendicular line. PM is perpendicular to x-axis. Then we get a right angle triangle. Then this right angle triangle PMO is called triangle of reference. With the help of this triangle of reference, we can find the remaining trigonometric function values. Okay, my dear children? Right. Sometimes they will give that angle theta lies in the third quadrant and they will give the value of any one trigonometric functions of theta. Then we have to find the remaining trigonometric function values of theta. Okay, my children. In that case, we use this figure. Figure 3. See here, angle theta lies in the third quadrant. They will give like this. Angle theta lies in the third quadrant. Then the triangle of reference. We have to draw triangle of reference. See here, angle AOP is theta. Angle AOP is theta. This angle is in the standard position. How can you say this angle is in the standard position? Vertex of this angle is origin and initial side of this angle is positive x-axis, that is OA is positive x-axis. Okay, my children. Then what is the position of terminal side? OP. In which quadrant terminal side lies here? Third quadrant. Therefore, we can say that angle theta lies in the third quadrant. The position of the terminal side decides the quadrant in which the angle lies. Understood this point, my dear children? Right. Now we draw a triangle of reference by choosing any point on the terminal side. We have chosen a point P. From this point P on this terminal side, we have to draw a perpendicular line on the x-axis. We have drawn PM perpendicular to x-axis. Then we get triangle OMP, a right angle triangle. With the help of this right angle triangle, we find the values of other trigonometric functions of the angle theta. Understood point, my dear children? Right. Now come to the next point, my dear children. Sometimes they will give angle theta lies in the fourth quadrant and they will give the value of any one of the trigonometric functions of angle theta, and they will ask find the remaining trigonometric function values of the theta. Okay, my dear children. In that case, we have to draw a triangle of reference. See this figure, my dear children. Figure 4. Angle theta lies in the fourth quadrant. Then draw the triangle of reference. They don't give this sentence, my dear children. They don't give this sentence. Draw the triangle of reference. We have to draw the triangle of reference. Here angle AOP is theta. Angle AOP is theta. Here we can say that angle AOP is in the standard position because vertex of the angle theta is origin and initial side of the angle OA is positive x-axis. These two conditions are satisfied. Then we say that the angle is in the standard position. Then the question arises, then what is the position of the terminal side? In which quadrant the angle lies? See here, what is the terminal side of this angle theta? OP. OP is the terminal side of the angle theta. In which quadrant this terminal side lies? Yes, it lies in the fourth quadrant. Terminal side of the angle theta lies in the fourth quadrant. Therefore, we can say that angle theta lies in the fourth quadrant. Understood this point, my dear children? Right. In that case, we have to draw triangle of reference. To draw a triangle of reference, we have to choose any point on the terminal side. What is the terminal side of this angle theta? OP. We can choose any point on this terminal side. We have chosen P, a point on this terminal side. From this point, we have to draw a perpendicular line on the x-axis. PM, we have drawn PM perpendicular to x-axis. Then we get triangle MOP, triangle MOP or triangle OMP. It is called triangle of reference for this angle theta. With the help of this right angle triangle, we can find the values of trigonometric functions of theta. Understood, my dear children? Right. Now come to the next point, my dear children. That is trigonometric ratios of allied angles. Here we are defining the trigonometric ratios of allied angles. What is meant by allied angles? Two angles are said to be allied when their sum or difference is either 0 or a multiple of 90 degrees. Understood this definition, my dear children? Allied angles means, I will repeat the definition. Two angles are said to be allied when their sum or difference is either 0 or a multiple of 90 degrees. The angles minus theta, 90 degrees plus or minus theta, 180 degrees plus or minus theta, 270 degrees plus or minus theta, 360 degrees plus or minus theta, etc. are angles allied to the angle theta if theta is measured in degrees. Understood this point, my dear children? These angles minus theta, 90 degrees plus or minus theta, 180 degrees plus or minus theta, 270 degrees plus or minus theta, 360 degrees plus or minus theta, and so on. All these angles are said to be allied to the angle theta if theta is measured in degrees. However, if theta is measured in radians, then the angles allied to theta are minus theta plus or minus theta, pi by 2 plus or minus theta, pi plus or minus theta, 3 pi by 2 plus or minus theta, 2 pi plus or minus theta, etc. Understood this point, my dear children? I will repeat this point. However, if theta is measured in radians, then the angles allied to theta are minus theta, pi by 2 plus or minus theta, pi plus or minus theta, 3 pi by 2 plus or minus theta, 2 pi plus or minus theta, etc. Understood this point, my dear children? Right. Using trigonometric ratios of allied angles, we can find the trigonometric ratios of angles of any magnitude. So, this concept of allied angles helps a lot to find the trigonometric ratios of angles of any magnitude. Okay, my dear children, right. Now come to the point number 6. In order to find the values of trigonometrical functions for any angle in terms of those of positive acute angle, we may follow the following algorithm. Sometimes the angle may be very large angle or very small angle. Okay, my dear children, in that case, how to find the trigonometric ratios of those angles? We follow these steps. Okay, my dear children, see the algorithm. Step 1. First step, see whether the given angle theta is positive or negative. First of all, we have to identify whether the given angle is a positive angle or negative angle. Okay, my dear children, right. If it is negative, make it positive by using the following. Sin of minus theta is equal to minus sin theta. Cos of minus theta is equal to cos theta. Tan of minus theta is equal to minus tan theta. Cosecant of minus theta is equal to minus cosecant theta. Secant of minus theta is equal to secant theta, and cot of minus theta is equal to minus cot theta. If the given angle is a negative angle, we have to use these formulae. Any one of these formulae. According to the question, we use the formula. Understood the step 1, my dear children? Right. Now come to step 2. Express the positive angle alpha obtained in step 1 in the form of alpha is equal to 90 degrees into n plus or minus theta, where theta is an acute angle. Here we got, this is a positive angle. Everywhere here we got a positive angle. Then we have to express this positive angle in the form of 90 degrees into n plus or minus theta, where theta, this angle is an acute angle. Understood this step, my dear children? Right. Now come to step 3. Determine the quadrant in which the terminal side of the angle alpha lies. Now we have to identify the terminal side of the angle, in which quadrant the terminal side of the angle alpha lies. Okay, my children, understood this step 3? Right. Now come to step 4. Determine the sign of the given trigonometrical function in the quadrant obtained in the step 3. Here in the step 3, we find the quadrant. Either it is first quadrant or second quadrant, third quadrant or fourth quadrant. According to that quadrant, we have to find the sign of the given trigonometrical function. We know in the first quadrant all trigonometrical functions are positive. We have already discussed the sign of trigonometrical functions in different quadrants. Understood, my dear children? We use that knowledge in the step 4. Okay, my dear children? Right. Now come to the step 5. Step 5. If n in step 2, if n in step 2 is an odd integer, then sin alpha is equal to plus or minus cos theta, cos alpha is equal to plus or minus sin theta, tan alpha is equal to plus or minus cot theta, secant alpha is equal to plus or minus cosecant theta, cosecant alpha is equal to plus or minus secant theta. If you observe here, sin theta, sin function changes to cos, cos function changes to sin, tan function changes to cot, secant function changes to cosecant, cosecant function changes to secant, and cot changes to tan. Do you observe these changes, my dear children? Right. The sign on RHS, here we have taken plus or minus, but we have to take either plus or minus. Only one sign should be taken. So the sign on RHS will be the sign obtained in step 4. So the sign depends upon the position of the terminal side of the angle, given angle. Okay, my children. So we use the result in the step 4. Okay, my children. Understood? Right. If n in step 2 is an even integer, if n is an even integer, then sin alpha is equal to plus or minus sin theta, cos alpha is equal to plus or minus cos theta, tan alpha is equal to plus or minus tan theta, secant alpha is equal to plus or minus secant theta, cosecant alpha is equal to plus or minus cosecant theta, and cot alpha is equal to plus or minus cot theta. Did you observe the difference between this case and in this case, my dear children? Here, if n is odd, then trigonometric ratios changes. Whereas if n is even integer, then trigonometric ratios does not change. See here sine, here also sine. Here cos, here also cos. Trigonometric ratios are not changing. Secant, here secant. Cosecant, here cosecant. Here cot, here also cot. After that, the sign on RHS is the sign obtained in step 4. Same rule here also we follow. To get the sign on RHS, we take the help of step 4. Understood, my dear children? Right. Now come to the next point, my dear children, that is domain and range of trigonometric functions. In this table we have written the domain and range of trigonometric functions. Sine function domain is real numbers. At every real number, sine function is defined. Therefore, its domain is real numbers. And function values, you know what is meant by range of a function. Okay, my dear children. So, close interval -1, 1. Sine function value is always lies in this interval, close interval -1, 1. Understood this point, my dear children? Right. Now come to the cos function. Cos function is defined at every real number. Therefore, domain of the cos function is real numbers. And its function values are closed interval -1, 1. Just same as sine function. Sine function range and cos function range same. Sine function domain and cos function domain also same. Remember these points, my dear children. These are very useful points. Okay, my dear children. Now come to the tan function. Tan function domain, the set of all real numbers, but we exclude these real numbers, or minus set of all x such that x is equal to 2n plus 1 into pi by 2 comma n belongs to z. This is the domain of tan function. And range of the tan function is set of all real numbers. Okay, my dear children. Remember these points, my dear children. Now come to the cotangent function or cot function. Cot function domain is set of all real numbers minus set of all x such that x is equal to n pi comma n belongs to z. This is the domain of cotangent function or cot function. And range of cot function is set of all real numbers. Okay, my dear children. Right. Now come to the secant function domain is set of all real numbers minus set of all x such that x is equal to 2n plus 1 into pi by 2 comma n belongs to z. And its range is or minus open interval -1, 1. Okay, my dear children, remember these points, domain and range of these trigonometric functions. And last one, cosecant function domain is or minus set of all x such that x is equal to n pi comma n belongs to z, and its range is or minus open interval -1, 1. Okay, my dear children, Remember this table, my dear children. This table is very useful in future also. Right. Now let us discuss the graphs of trigonometric functions one by one. Okay, my dear children. See the first one, graph of sin x. Graph of sin x. In the examination also they will ask, draw the graph of sin x, draw the graph of cos x, draw the graph of tan x, draw the graph of cosecant x, and so on. Okay, my dear children. So we have to get the knowledge of graph of trigonometric functions. Okay, my dear children. See this one. This is x-axis and this is y-axis. On the x-axis, take the multiples of pi by 2. In general, we write 0, 1, 2, 3 and so on. Here, left side minus 1, minus 2, minus 3. On x-axis, generally we take that numbers, that real numbers. But here, on x-axis, take multiples of pi by 2. So, 0, pi by 2, here pi, 3 pi by 2, 2 pi and so on. Left side minus pi by 2, minus 2 pi, minus 3 pi by 2, minus 2 pi and so on. Okay, my children, remember this point. On x-axis we have to take multiples of pi by 2. Now come to the y-axis. Here 1 minus 1, because the range of sin x is minus 1 to 1 only, not less than minus 1, not greater than 1. We don't get the graph of sin x. That is why we are not writing here 2, 3, 4, here minus 2, minus 3, minus 4 and so on. No need to write these numbers on y-axis. Okay, my children. Now observe this one. Here from minus 2 pi 2, it is increasing up to 1. That curve is increasing up to get the 1. After 1, it is getting downwards till minus 2 pi. Again it is decreasing until it is getting minus 1, until it is reaching minus 1. After that again the curve is increasing and increasing like this up to 1. Again here again decreasing up to here minus 1. If you observe this graph, here from this number we left this number like this, we have drawn a parabola or U shape. Again we have leaving this number and we are connecting these two numbers, and we are leaving that number, we are connecting upwards like this, and we are leaving this number, we are connecting these downwards. Okay, my children, remember the graph of sin x. Okay, my children, right. Now come to the graph of cos x. Now we are drawing the graph of cos x. Same as in the case of sin x, we have taken x-axis and y-axis. On x-axis, multiples of pi by 2. 1 unit is taken as my pi by 2 multiples on both sides. Here on y-axis, here 1 minus 1. Okay, my dear children. Cos 0, 1. Cos 0 value is 1. Cos pi by 2, 0. Okay, my dear children. So from here onwards it is decreasing, still decreasing. Afterwards pi by 2 still decreasing till minus 1. Cos pi is equal to minus 1, and it is increasing. Cos 3 pi by 2 is 0, and so on. It is increasing. Cos 2 pi is equal to 1. Similarly, left side from y-axis, see here decreasing. Cos minus pi by 2 is 0, and it is decreasing. Cos minus 2 pi is equal to minus 1. It is increasing this side like this. Understood this graph, my dear children? You remember sin x graph and cos x graph. In general, you have to remember, you have to practice the graphs of sin x and cos x. These two are enough. Sometimes very rare cases they ask the graphs of other trigonometric functions. Okay, my dear children, but mostly they will ask the graphs of sin x or cos x only. Practice the graphs of sin x and cos x well. Okay, my dear children, right. Now come to the graph of tan x. Graph of tan x. Same procedure. On x-axis multiples of pi by 2 and on y-axis real numbers. Okay, my dear children, right. See here, tan 0 is 0 and tan pi by 2 undefined, not defined. So the curve increases like this infinitely, but it does not touch this line x is equal to pi by 2. Similarly here, x tan minus pi by 2 and not defined. Okay, my children, tan pi 0, tan 3 pi by 2 undefined. So the curve increases like this. Here this side decreases. Here also the graph. So minus 3 pi by 2 minus pi by 2. Graph will be like this. Like this. Minus pi by 2, pi by 2 interval. Pi by 2 to 3 pi by 2 interval. Graph like this. This entire graph represents the graph of tan x. Okay, my dear children, I am not explaining the graphs of the remaining 3 trigonometric functions because in the examination point of view they are not given, they are not important. Okay, my dear children, just to practice the 3 trigonometric functions, but give more importance to draw the graphs of sin x, cos x and tan x, my dear children. Okay, my dear children, practice well the graphs of sin x, cos x and tan x. Okay, my dear children, right.